Okay, here we are on our last 3 pages of Module 1, Lesson 5. So we have page H, I, and J left. So this is where we're going to formally introduce, define, explain what PEMDAS means. And as I said before, a good way to remember it is please excuse my dear Aunt Sally. So parentheses is P. So this is parentheses and other grouping symbols. And in one of our past videos, we learned that absolute value are some of those. Brackets can be used in place of parentheses. And when we have a fraction bar, there's imaginary parentheses on the top and imaginary parentheses on the bottom, where you do the numerator first, get an answer, denominator second, get an answer, and then you divide the two. So those are all the different grouping symbols: parentheses, brackets, absolute value, and when we have a fraction in the problem, numerator done, then the denominator done, because there are imaginary parentheses around each one. So you never start dividing first or do your fraction. You always have to do your operations in each of those first. So that's what P stands for. E stands for, and let's just go ahead and write please excuse my dear Aunt Sally again, in case anybody doesn't remember that. Just to remember PEMDAS, my dear Aunt Sally. Okay, next we have E, and E are exponents and radicals. So it would be like what we were doing earlier, 3 to the 4th power, but it would also be this square root of 9, which you'll learn in later classes is really 9 to the 1/2, and that's why radicals are also in the exponent category, because all radicals can be written with fractional exponents. And then multiplication and division done left to right. So one does not take precedence over the other. We simply go left to right, done left to right. And then last but not least, whenever we're doing a math problem, so first we clear the parentheses or absolute value, then we do any exponents and radicals, then we clear up all the multiplication and division, and last but not least, we do addition and subtraction left to right. And that's the order you do every math problem for the rest of your math life. Following those. So they're not going to say, hey, use order of operations. They're just going to assume you know. And we have 3 of these on our upcoming test, so that means you'll probably know the quiz is over sections 1 through 3. So it won't be on the quiz, but it will be on the test. And it's towards the beginning of the test. It's like problem 4, 5, 6. So I highlighted these to draw your attention to them, to be sure and look at those before you take your test, to remind yourself about order of operations. So, and it's just gonna probably say simplify on your test in Alex. Maybe it might say perform the operations. So no parentheses in this problem, done. Exponent, oops, there we are. Got to do that first if there aren't any parentheses, because we just go down the line. And just like I said earlier, you can do this in groups of 2. 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81. So this would turn into 8 divided by 4 plus 81 minus 20. So 8 divided by 4, we've got rid of the exponent, so we can cross that off. And then remember, these are done left to right, these are done left to right, so exponents are done. So now we do any multiplication and division, which there's only one. 8 divided by 4 is 2. And then I've seen so many students get this far in the problem and then they go out of order and try to do it. No, addition and subtraction has to be done left to right as well. So don't mess it up on the last step. So we stay going left to right. This turns into 83 minus 20, which is 63. Okay, let's do one more together and then you guys can try some. So, parentheses in this problem. So we have to go in here and do this first. And then I see an exponent there, so we need to take care of that. So 12 minus 4, parentheses, 5 times 5 is 25 minus 10. And then divided by 6. So we still haven't cleared the parentheses, so we're still on P. And once you clear the parentheses, you usually, if there's a number there, just put a dot in between the answers. So this comes out to be 15. So we would rewrite this as 12 minus 4 times 15. Because do you all know that when there's a number right next to parentheses, that means there's an imaginary times sign there. So when the 15 comes out, you just put a times sign in between it and 4. Okay, so parentheses are done. There are no exponents, so that means we jump to multiplication and division. So skip this, so that means we go here first. So 12 minus 4 times 5, well, I guess I should do it like this, 15 times 4, because order doesn't matter, right? 20, carry your 2, 4, 5, 6, so that would be 60. A negative times a positive, one negative, negative answer, that's why I brought the negative down. And we still have to clear up the remaining multiplication and division. So again, remember, this is a negative sign. A negative divided by a positive, one negative, negative answer. So I do 12 minus, and 60 divided by 6 is 10. And 12 minus 10 is simply 2. So as long as you keep PEMDAS there and follow the order, super easy problems. Okay, go ahead and shut off your video, do the last two, and then join me back and we'll go over them. Okay, so parentheses first. So that leaves me with, and remember what I said, when you figure out an answer, this answer's 4, you have to put a times sign in between 2 and 4. Because there's an imaginary times right there. So that would be 2 times 4 squared. So our parentheses are done. Next we do exponents. So 2 times, and this is 4 times 4. Remember, not 4 times 2. 4 times 4 is 16. 2 times 16, 32. Not bad, right? What I see a lot of students do on this one on the test is they distribute the 2. Never, never, never. Because parentheses are done before exponents, so you would never distribute that negative because you have to do the parentheses first. So it would never be distributed to each of those. You will not get the right answer. Instead of 16, you would have gotten 64 minus 16, which is 48. So not even close. Parentheses first. Once you get your answer, you drop the parentheses and be sure and put a times sign in, exponent second, and then we multiply. And this one I see a lot of students miss on the test as well because they subtract. So like, oh, before I go to parentheses, I got to subtract 7 and 5. Never, never, never. Parentheses are first, multiplication's next, subtraction is very last. So do not subtract those, as tempting as it may be. So we're going to do 7 minus 5, because we're working on parentheses first. 2 used as a factor 3 times means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So this is my new problem. And then I still have to do this. This is 11. So now when I drop the parentheses, remember I replace it with the times sign. So now it's 7 minus 5 times 11. And there's one just like this on your final exam too. And so many people miss it. If they don't subtract here, then they miss it at the end because of the sign. So just go nice and slow. No hurry. So multiplication comes before subtraction. So 5 times 11 is 55. A negative times a positive, one negative, negative answer. And this is where most students miss it on the final. So they realize that it's a subtraction problem because one's positive, one's negative, same, add, different, subtract. So we go over here and we subtract 55 by 7, borrow, and we get 48. And then that's the most common wrong answer on the test, because students went too fast and they didn't do the second part. When the signs are different, subtract and keep the sign of the larger. And if you think money, you would know that. If you only have $7 in your account and you go out and spend 55 on your debit card, you're in the hole. That's negative 48. And that's the most missed problem on the final. And mostly it's missed because students forget the negative. Couple students subtract first, forgetting order of operations, but that's the most missed thing. Losing that negative. Always keep the sign of the larger. Okay, let's do these last 2 pages. Perform the indicated operations by computing the result in parentheses first as the order of operations necessitates. So what we're trying to find out here is addition, and the word is called associative. Associative means we are changing the parentheses. And the way I remember it, I always have tricks to remember everything. I remember commuting for commutative, home to school, school to home, switch the order. I remember associative because the parentheses associate these two numbers together on this side, and they associate these two together on this side. So that's how I remember associative property, because the parentheses are associating. So let's see if the parentheses matter in addition. So this would be 37, if you do parentheses first, plus 10, which gives me 47. This one, doing parentheses first, 14 plus 10 is 24. And when I add those, 47. So I can conclude that the order of the parentheses, which two numbers they're around in addition, does not matter. So that means addition is associative. Associative means associating different numbers together does not change the answer. So addition is associative. The two answers are the same. And that would be a yes. I forgot to put a yes there to answer the question. Okay, so you can associate any two together, same answer. So let's see if subtraction is associative. 40 minus 15, 40 minus 10 is 30, minus 5 more is 25, minus 5 gives me 20. Here, doing parentheses first, 15 minus 5 is 10, 40 minus 10 is 30. So first I group the first two together, on the second one I group the last two together, and I see subtraction, the answers were not the same, so that means subtraction is not associative. You can't do any order you want in subtraction, but you can in addition. So subtraction is not associative. And it's pretty easy to remember. So in commutative property, addition and multiplication were commutative. Well, guess what? Addition and multiplication are also associative. Subtraction and division are neither. So next we have 12 times 3 is 36, times 4, we can go over here and do that, 24, carry our 2, 12, 13, 14, that's 144. And on this one, 12 times 12 is also 144. I have my squares memorized. I try to memorize them to 20, but sometimes I forget some of those. So because we got the same answer, multiplication is associative. And last but not least, we try our division. So we have 60 divided by 30, 600 divided by 30. And remember how I said you guys can do this and use division like this? You just have to keep it in the same order. And you guys remember this trick from previous classes? You can cross off the same number of zeros. So this is really just 3 into 60. 3 goes into 6 twice. Subtract. 3 goes into 0 times. So that is 20. So 20 divided by 5 gives us 4. And then doing the last two, 600 divided by 30 divided by 5 is 6. How many times does 5 go into 30? And then again, you can do this. 6 divided by 600. Well, 6 divided by 6 is 1, and then add 2 zeros. And I can see the two answers are not the same. Therefore, division is not commutative, as we guessed. Or associative, sorry. Division is not associative. So you learn two properties in this one, commutative and associative. Commutative is when you change the order. Associative is when you change the parentheses. And here's a pretty good description of associative. Highlighter worthy, I think, to remind yourself about that. A mathematical operation, we'll call it multiplication, is said to be associative if where you place the parentheses does not matter. The tables you created above, which of the 4 operations have the associative property? And we said that was addition and multiplication. And explain your answer, same answer. So As long as we get the same answer when we change the parentheses, that means they are associative. Uh-oh. Okay. The timer disappeared. I thought the video had stopped, but I must have just clicked something. Okay, one last page. Okay, partitioning a flower bed. That means breaking it up into pieces. Use the diagram and information below to answer the following questions. Recall that you can find the area of a rectangle by multiplying its length times its width. So we had that in a previous video. Length times width is how we find the area of a rectangle. So this is Ramona's flower bed. It has a total length of 10 feet and a total width of 4 feet. She is going to plant morning glories and tulips. So here's the tulips and here are the morning glories. So determine the total area of the garden by multiplying its length times its width. So total area means the whole big rectangle. So the whole big rectangle would be 10 times 4. We would ignore these partitions because they're asking for total. So area equals 10 times 4, which is 40. And remember how I told you area on another video is always square units. So we would write feet squared. And we learned more about that in Module 4. Now they want us to see if we find the area of this and the area of this and add them together, if we'll get the same answer as that. So what's your prediction? So total number of square feet with tulips. So now we're just doing tulips. So if that's 4 feet over there, we know this is 4 feet here. So tulips will be 3 times 4. So the area equals 3 times 4, which is 12 square feet. That's just for the tulips. So the 4 for the width, the 3 for the length, or vice versa. Okay, now determine the number of square feet that will be planted with morning glories. So that would be a 7 and 4 would be the dimensions for the morning glories. 7 times 4. So area equals 7 times 4. And remember, on all three of these, order doesn't matter, it's multiplication. So that would be 28 square feet. So determine the total area by adding these two together. Because isn't the tulip area plus the morning glory area the total area? So we get 12 plus 28, and that is 40 square feet. Oh, sound familiar to you? Look at that. Same answer. So it doesn't matter whether we partition it and do it by pieces, or if we do the whole thing, we get the exact same answer. Because how could the area differ, right? Using the equation below, describe how it represents the two ways we found the total area. So this is the width times the length, and this is width times length plus width times length. And we're going to learn that that is called the distributive property, another property. So let's write that down and highlight it because I know it's on your test. Distributive property. It says that when you have 4 times 3 plus 7, to distribute means this. So it means 4 times 3 plus 4 times 7, which is 12 plus 28, or 40. So that is the distributive property of addition. It also works for subtraction. 4 times 3 minus 4 times 7. So distributive property of addition is taking the number outside, we know there's an imaginary times there, and multiplying it by the things inside. So 4 times 3 plus 4 times 7. And that would be another thing I would highlight, since there are some questions about properties on your test. Let's go ahead and write square feet here just to be politically correct. And I believe we are finally done. So Module 1, Lesson 5, over. So I'll see you for Lesson 6. Bye.